Hello and welcome to Maths with Jacob. This lesson will focus on equivalent ratios. Equivalent ratios follow the same rules as equivalent fractions. To find equivalent ratios for any given ratio, we use the following rule. Multiply or divide each term in the ratio by the same number. This maintains the exact value of the original ratio. Examples. Find the value of the shape in each of the following ratios so that the ratios are equivalent. So for the first example, we have 2:3 equals 8 is to the square. So we have to find the value of the square. So just for this first example, I'll do some words, so a worded description, just to let you know how we do it. If we look at the first term in each ratio, that is the 2 and the 8, we can see that the first term in the second ratio is obtained by multiplying the first term in the original ratio by 4. What that's saying is we get the 8 by going 2 times 4, so that 2 is multiplied by 4. Hence, we multiply the second term in the original ratio by 4 to obtain the value of the square. So if we multiply that term there by 4, that should give us the value of the square. So 2:3 equals, now we've ascertained that we might have to multiply each of those by 4, that by 4 and that by 4, to get each term in the second ratio. So 2:3 is 2 times 4 is to 3 times 4. So 2:3 is 8:12. So the square must be 12 because the square is second. So the square must be 12. So 2:3 is equivalent to 8:12. Number 2. 1:7 equals 5:2 the triangle. Now, if we look at the first term here, how do we obtain this term? We multiply the first term by 5. So basically, multiply both of these terms by 5 to give us the second ratio. So that's 1 times 5 and 7 times 5. So 1:7 is the same as 5:35. So the triangle is 35. Number 3. 3:8 equals the star is to 80. We went from 8 to 80. How did we do that? We multiplied that term by 10. So that's what we have to do. We have to multiply both of those terms by 10. So each of them has to be multiplied by 10 to give us the second ratio. The reason we multiply each of them by 10, as we saw in previous videos, it keeps the value of the ratio the same. So 3 times 10 is to 8 times 10. So 3:8 equals 30:80. So the star is 30 because the star was first. Number 4. The heart is to 48 equals 5:16. Now it's quite easy to swap these around. There's no problems. It's exactly the same situation if we swap these around. It's a lot easier when you have the simplified ratio on that side because you just do multiplication. A lot easier, as we saw in the first 3 examples. So how did we get from the 16 to the 48? 3 times 16 is 48. So we multiply each of these terms by 3. So 3 times 5 and 3 times 16. So 5:16 equals 15 to 48. So the heart is 15, because the heart was first. 72 to the sad face equals 36 to 11. How do we get from 72 to 36? Well, we can do division, but if we swap them around, if we put the 36's to 11 first, and the 72 to the sad face, or smiley face, it doesn't matter. That's interesting, isn't it? That's changed from a sad face to a smiley face. That's okay. So, basically, we multiplied 36 by 2 to give us that. So multiply each of these by 2. So 36 by 2 and 11 by 2. So both of those are multiplied by 2, which we've done here. So 36 is to 11 equals 72 is to 22. So the face will be 22, because the face was second. See, the face was second, so the face is 22. So this video has given us some examples where we've seen how to work with equivalent ratios, and when we're given one of the numbers that is unknown, we can find it. We can find it, and it's exactly the same as equivalent fractions. You have to multiply each term by the same number to maintain the value of the ratio.